Okay, here we have example 2 for math 7, probability of dependent events. So we're looking at a bag and it has 2 blue marbles and 3 red. One marble is drawn from the bag and then a second marble is drawn from the bag. Just based on that sentence, we don't have enough information to determine if it's independent or dependent because nowhere in that first sentence did it say if replacement was happening. Huh. So, part A. What is the probability of picking a red and then a blue marble if replacement occurs? This is an independent event because replacement occurs. So this is just like what we were practicing yesterday. So the probability of you picking a red marble, still 2 events are happening. So 2 fractions. So red marble is 3 out of 5 total. And tells us we need to be multiplying. Blue marble would be 2 out of 5 because, again, replacement occurred. So after I picked that first one, I put it right back. 3 times 2 on the top gives me 6. 5 times 5 is 25 for 6/25, which converts to 24 hundredths or 24% if you're a percentage person. All right, part B here. What is the probability of picking a red and then a blue marble if replacement does not occur? So you might be thinking this is the same thing as part A, but it's not. It's slightly different because of that keyword of replacement not occurring, which makes this a dependent event. So the probability of picking a red marble stays the same. Red marble, I still have 3 out of 5. But now that I did not put that red marble back, and I just want to stress that 3 out of 5, that does not mean I picked 3 red marbles. That means that out of the 3 red marbles, out of 5 total marbles, I picked out one of them, and I did not put that back. Keeping that in mind, what is the probability of me going into the bag and picking out a blue marble? Well, 2 of the marbles are blue out of how many total? And this is where it changes. It's no longer out of 5 total. It's out of 4 total because we did not replace the first marble. So 3 times 2, 5 times 4, 6 over 20, which is actually 3/10 or 30%. How do those 2 probabilities compare to each other? Just a little sentence. Which one's more likely to happen? Event B is more likely than A. Why? Because it has a higher percent or a higher probability. Okay, part D. Ooh, this is an important one. Go star by this one. And actually, this one's important too. So we're actually going to star both of them. Star, star, stars. So part D, the first marble drawn is blue. What is the probability that the second marble is red if replacement does not occur? So again, we have a does not occur, making this dependent. But the trick to this one is that if you look, they're only asking you to find the probability of one event. They're asking you to find the probability that the second marble is red. That first sentence saying the first marble drawn is blue, that is not asking you for the probability of it. That is a statement. They are telling you that the first marble picked was blue. If you picked that blue marble, kept it in your hand, and did not put it back, what is the probability of you now going back in and getting a red marble? Well, out of all of my marbles, only 3 of them are red. Out of how many total? There are no longer 5 total because I picked that first blue marble. So there are 4, so 3 red out of 4 total after we took out the blue. That one blue. So watch out for those questions. That was only asking for the probability of one thing, hence one fraction. Party. What is the probability of drawing 2 red marbles? Replacement does not occur. So again, a dependent event. This is similar to the question that we did yesterday, talking about 2 somethings or anothers. So how many events are happening here? Still 2 events. 2 events means I need 2 fractions. Even though it says 2 red marbles, we're not ever picking 2 things at the same time. This is really asking me for the probability of red and then the probability of red again after I already picked a red. So, starting fresh, the probability of me just picking a red marble is our typical 3 out of the 5 total. But now that I've picked that 1 red marble and I have it and I am not putting it back, what is the probability of me going back in and getting a second red marble? So we no longer have 3 red marbles. We're down to 2 red marbles because I'm just going to scooch this over again. 3/5 and because we already picked a red. So there's not 3 red, there's 2 red. And if there's 1 less red, there's also 1 less total, getting us down to 4. 3 times 2 is 6, 5 times 4 is 20. Boom. So that example will be very similar to the questions you're dealing with on your practice problem.